Thanks, Anya. I just need to be able to share my screen. If you can maybe
Yep, you
allow
should
me
be
to do
able.
that. Yep, now I can. Get the window going here. I think Lisa's going to kick us off with the first few slides.
Yeah, great. Thanks, Ryan. Welcome, everybody. I'm really pleased to introduce this session. This is our second training session that we've had on what we call the Embodied Carbon Toolkit. Um, as mentioned, I'm Lisa King with the City of Toronto. And do you want to go back to the speaker slide, Ryan? Sorry. Ryan Zizzo is with Mantle Developments, and Kelly Doran is with the HAF Studio, HAF Climate Design. And these have been our partners and our consultants on two phases of work that we've done that has been funded by the Atmospheric Fund. And you can just hold there for a sec, Ryan. So sorry, we're jumping around a bit, but so the agenda today is basically we're going to give you the background on the two phases of study work that we've done, but we're really going to hone in on this toolkit that's been developed, and it's really meant for Ontario municipalities, but we've used Toronto as kind of the case study to develop it. And it's been divided into three parts, which focused on construction circularity, design principles for low carbon buildings, which I think you'll find really interesting, and procurement specifications. So to help municipalities actually set these things out. And of course, it's a very interdisciplinary topic. So when municipalities take this up, we really have to do it in a cross-divisional way using all the tools we have. And how long are we going for today, Ryan? Can you remind me? 1 hour, right? So we hope to have a good amount of time for discussion and questions at the end. So in Toronto, like most municipalities in Ontario, we have a climate change plan. It's called Transform TO. But in 2021, when it was taken through City Council for approval, Council moved up the net zero agenda and objective for our whole city, a net zero by 2040 target. And we always do intensive modeling on GHGs. Every couple of years, we're just in the process of updating that again and looking at the different sectors that we can affect. And with that change to net zero community-wide target by 2040, we had to then look at, okay, how are we going to make deeper cuts to GHG emissions? And how are we going to move beyond, in the case of buildings, just addressing operational emissions? Still very important and still something we do through something called the Toronto Green Standard. But we need to look at how we can make emissions cuts faster and effectively. And so embodied carbon provides one of those opportunities trying to address that. We started with a big study called Regulating Embodied Emissions in Buildings. It was kind of a policy primer, again, funded by TAF, and we did that work leading up to 2022. There were two benchmark studies going on at that time. So one was done for the low-rise construction sector, and that was led by Builders for Climate Action and Chris Magwood. And then there was the other study that we're going to talk about a bit more, which was for Part 3 large buildings. Next slide, please. So benchmarking was something we really wanted to do to start with because we wanted to be able to set some kind of targets within our green standards. So our green standards set out regulatory requirements for new construction. And most Ontario municipalities have green standards now, or they're in the process of creating them. They apply through the planning or development approvals process. So in the first benchmark study for Part 3 buildings, we looked at 41 projects and dove deeply into, and this was mainly the HAF Studio doing this, breaking them apart, looking at what the contributions to their embodied carbon footprint were using the LCAs that were developed. But then, identifying the median, and that helped us to establish some targets. And you can see that bar graph, the blue bar graph, shows you just exactly where we kind of landed. But most building types were falling below about 435 kilograms per meter squared. And the low rise study that had a really big sample size too. It had over 500 buildings in there, and everything was falling kind of below the 250 kilograms mark. So we needed to be able to set benchmarks or targets within our standards, but we also wanted to be able to start tracking and monitoring and pulling more data by asking for a life cycle analysis submission. Next slide. And then as part of that phase 1 study, the policy primer, benchmarking of large buildings, we also took apart some LCAs related to some city building projects. And what we found was, and not surprisingly, probably for the audience here, that the top 3 culprits of embodied carbon were around concrete, steel, and insulation, and the volumes of those materials, the types of materials. And so by looking at a couple of case studies and working with our capital project managers, we were able to, for one thing, raise their capacity around what embodied carbon is, how LCAs are done, and how they might, without little cost implication, reduce the embodied carbon footprint of their buildings in design. And we were able to influence those projects as well. Next slide, please. And so out of that benchmarking study, there are quite substantial recommendations that Ontario municipalities can use, and they were trained on, either related to designing buildings and some of the policies around that, like even, parking requirements, eliminating parking requirements and adding maximum parking requirements, ways to design buildings so that you're using less volume of materials, promoting reuse, and so on. And then around the material side, looking at what municipalities could start to prescribe around concrete, steel, wood, and insulation, being 4 big areas in structural and envelope materials we could affect. But we also, from there, wanted to look into more detail, which is the setup for the phase 2 and the toolkit that we're talking to you about today, to give even more guidance to municipalities on these 3 topic areas: procurement, setting up procurement specs, circularity, how do we promote reuse of materials, and careful demolition and deconstruction, and then in urban design itself, what can we do in the design of buildings to reduce their footprint off the bat. And with that, I think I'm passing it over to you, Ryan, here. Oh no, one more slide, yeah. And then in 2023, very important. So this is the thing that I lead and manage, is the Toronto Grain Standard, those requirements for new buildings. We were able to add mandatory targets for city-owned buildings from the benchmarking study. And then we added voluntary targets or caps for the private sector, Part 3, and for Part 9 buildings using those benchmarks that I talked about. And so that's kind of where we land right now. We do ask for an upfront LCA demonstrating compliance with those targets. And we are continuing to do further work to delve into developing targets for more building types going into 2025 in another study that we're doing, because we're finding some buildings are challenged with these targets, but for the most part, most can come in under those kind of caps that are listed there on the right-hand side. Okay, thanks very much, and pass this over to Ryan to take you through the toolkit.
Great, thanks, Lisa. So as Lisa mentioned, this phase 2 that was building on that previous work, we looked at these 3 topics, and the key goal and idea was to provide some recommendations, both to municipal governments, but also to the general design community on how they can do things a little bit differently in each of these 3 topics to really drive down embodied carbon. So through this process, which was partially funded through the TAF, the Atmospheric Fund, so we want to obviously say thank you to them for supporting this work. But in this work, we did a large jurisdictional scan to look at what is happening both in Ontario and in Toronto and also internationally for best practices on these topics. We had a number of workshops with key city staff and working group members to inform some of this. We had many meetings with various stakeholders on this, including technical experts on these topics. And then the HAF team did a number of whole building life cycle assessments and iterations of those to understand the life cycle impacts or the embodied carbon impacts associated with the different design challenges. So Kelly will be speaking to that in a little bit. And they designed some counterfactual analysis to guide that embodied carbon reduction. So we already do have some preliminary results posted on the Mantle website, but we are going to be releasing this toolkit and executive summary very shortly as well. So we'll walk through the toolkit in a little bit, but basically it's broken down into an interactive Excel, Google sheet, so that there was kind of too much information that we think that was relevant to get it down into a single checkbox sheet. We wanted to kind of have these breakouts of what is the topic, what is the context, what is the recommendations, and then we even have resources and examples and other columns further to the right. So Kelly will kind of walk through that a little bit towards the end of the talk before we open it up for discussion. And then another one of the things that we did was talked with two separate City of Toronto projects, their project teams and the city representatives and all the various consultants associated with them. And we kind of walked through the recommendations and the topics and said, how could this be applied on this specific project? So these were the two projects that we did that with. The first is the John Innes Community Recreation Center, which is the new community center redevelopment at Moss Park. And then the second one is the rapid housing, really exciting rapid housing mass timber project at 113 Dundas Street West. And both of those projects had some really interesting feedback for us that helped us refine the toolkit. And also both of them are looking at implementing a number of the strategies that are being recommended. So the community center, for example, they're going to be taking a very hard look at low carbon construction fuels as part of this, looking at more biodiesel and maybe even electric equipment. So that's something that they really were able to take away from the recommendations and hopefully apply. And then for Dundas Street West, it was looking at deconstruction. Actually, they've decided to do a full deconstruction because there's a current houses on the site right now. So instead of just doing the traditional demolition, they're going to have a thoughtful deconstruction and try to look for opportunities for more circularity. So both of those were some really exciting outcomes. So we're going to give a really brief overview of the key findings and topics. So I'll do construction circularity first, then I'll hand it over to Kelly for urban design, and then I'll come back for the procurement one. So we're going to go quickly to just through some of the high level topics here. So most people on the call kind of understand what we mean when we say construction circularity, but this graph just quickly shows the idea is not to just make something, use it once, and then throw it out to the landfill. It's really to find ways to reuse and recover and ideally minimize landfill or eliminate landfill in the future and having more of a closed loop system in our construction process. So many of you have also seen graphs like this, that hierarchy of how we can reduce carbon in our buildings and our design. And the first thing is really to use less stuff. And in part of that, it is to build less, right? Let's find ways that we can reuse what we already have, be that a whole building, if we can, reuse that in the new development instead of just demolishing it, or maybe it's reusing salvaged materials that have been, deconstructed from other sites. So that's what we're focusing on when we talk about circularity. And in Toronto, we do some circularity quite well. I'm sure everyone that lives in the city or has visited the city has seen lots of sites like this across the city. And this is a form of circularity. This is reusing, facades. But this is mainly being done currently from a heritage perspective, right? There's obviously a heritage value in these, facades and what these buildings, look like from the exterior. But we could probably do a lot better than this if we start making these decisions from a carbon perspective as well, because, I think there's a lot more carbon that goes into those steel structures than there is that we're saving in the brick, right? So I think maybe I'm not saying we shouldn't be doing this, but maybe we should also save all those slabs and columns and beams behind those facades instead of just demolishing them like we're doing right now. So I think there's new solutions that we could implement if we think about how to do this in the lowest carbon way possible. So circularity is really interesting. As I dive deep into this, I realize there's so many wins when we take circularity seriously. It really supports local jobs. The city of New York has a recent circularity strategy that they released, and it's being supported by the economic development folks in New York. So not the climate people, not the waste people, it's the economic development people, because this is a real way to create new local jobs. It obviously improves culture and heritage by retaining those materials, as we talked about. It's also lower carbon, less waste goes to landfill. We're extracting less waste for new materials, and it can actually be faster if we're reusing what's there and not having to go through a demolition process and a rezoning process. So there's quite a lot of wins when we look at circularity. So just to touch on a couple of the big topics on what we mean by them. One is supporting building adaptation and reusing what's already there. this can be, when we have recommendations, some of them are for governments and some of them are for project teams, but for everyone involved, we should be thinking of ways to use what's on a site. So this example in the bottom, we already have some great examples. This is 488 University. The residence is on University Avenue. And this was an existing office building that they actually took the facade down, put up an exoskeleton and a transfer structure on top, and then built something like 30 stories of residential above that without demolishing the building below, right? So this is something we should be doing more of and finding ways to build around and above existing structures instead of just demolishing them and sending them to the landfill. Another recommendation is around having what we're calling pre-development and or pre-demolition audits. And in some municipalities, they call this circularity audits. So this would be before a demolition or even approvals for a new redevelopment happen, is to have someone do a thorough audit of what's on the site. It could be the buildings themselves, or it could be the materials within that, and have a plan on how to actually reuse those in the most effective way. We do actually have a policy in Ontario that has some elements of this. It's Ontario Regulation 102/94. It's a provincial policy that requires material waste audits to be done. But unfortunately, we found in our research that it's not really being implemented very thoroughly across the province. So wanted to point that out. And again, there's a much more context and links in the actual toolkit. So you can dive deeper in once you take a look at the toolkit itself. Another one an idea we saw, this example is from the City of London in the UK's. They have a document called the Circular Economy Statements that applies to large redevelopments in the City of London. And they've created this decision tree where basically the development team is asked a series of questions about the building and the site. And basically, based on how you answer that, it recommends from retrofit and retain all the way down to demolish and recycle. So some really interesting thoughts have gone into this, and there's been some folks in Ontario working on an Ontario version of this from the heritage perspective, but wanted to kind of put this idea on people's radars, and maybe municipalities might even in the future start revising the fees associated with a development, depending on where they're landing on here, or maybe having a refund if you're doing, the most carbon advantageous solution or something like that. So this is something that's definitely, I think, worth a little bit more thought on specific projects going forward. And then another big category was how can we, again, move away from demolition as the default and move towards deconstruction and disassembly, a thoughtful way of removing the materials so that they can be reused without, being destroyed in the process. And we have, again, there's examples in the toolkit that the City of Vancouver has a deconstruction ordinance that's been in place for a number of years now. I think there's about 6 or 7 other municipalities in North America that have deconstruction requirements. So this is something that we're probably we're probably ready for something like this in Ontario. And once we are deconstructing our materials, we then have to put them somewhere and have some kind of a market in place so that other designers can use them in their projects. So we want to start putting out the idea of creating and supporting these what we're calling secondary material markets. And there is some really exciting discussions going on in Ontario about this right now. There's some recent databases that have been going up and some recent companies that have just launched that are actually focused on this. So this is definitely something that we're going to be seeing a lot more of in the future. And maybe we start with one material, for example, bricks, right? I could see a municipality saying any reusable brick should go to this material salvage market. And then we have a good supply of that material. And then all the designers know, hey, let's get our brick from the secondary market, and we can have a lower carbon impact and have a really great circularity story there and a heritage benefit, right? So again, lots of multiple benefits here. Something we could think about is adding requirements for these salvaged materials in new buildings. So it doesn't have to, be the whole building made about salvaged material, but if we start with, 1% of our project from a salvaged material, that should be relatively easy to do, and it would start providing the demand for this type of a market. So we saw some really interesting examples of that in other jurisdictions. So that was a quick whirlwind of the topics from a circularity. So I'm going to hand it over to Kelly to talk about the urban design piece now.
Great, thanks, Ryan. So some background on the urban design when we started this work with Lisa a year and a half ago, and this is all funded by TAF, and in the original, in that grant application, you could see we had identified unintended drivers of embodied carbon in city guidelines and city bylaws. And so that was really the motivation to begin looking at how those existing guidelines could have unintended consequences. Next, please. And so to contextualize this conversation a little bit, we looked at 3 documents, the mid-rise, low-rise, and tall building urban design guidelines, but I think it's important to contextualize these guidelines and the documents that they build upon from an urban design perspective. So back to earlier studies, specifically the 1990 Sun, Wind, and Pedestrian Comfort Study, the Bosman study that they refer to, as well the initial review for tall building guidelines in 2006, and then also to see these sitting alongside the evolution of the green standards over the last 20 years. Next, please. And what's kind of interesting in some of these earlier documents to kind of contextualize the study is that in the tall building guidelines of the 2006, you can see there's an understanding how block pattern and urban design has really moved and changed between the 50s, the 60s, and the 80s. And I think what question that we have in the study is like, what is the urban block pattern of today? How is it responding to the challenges of today? Next, please. And how do our understandings of the drivers of what was happening in 1990 with the Sun, Wind, and Pedestrian Comfort Study that really shaped a lot of our assumptions around what good urban design is and has been for the last 34 years? How are they different now? And you can see here a part of the city that's really pushed out of the envelopes that were described by the study. And you can see on the left that the sketch there being developed in 1990, which is really an important part of this, is that this study specifically, made a comment that said that the city and designers don't necessarily have the tools at their disposal to help do the kind of analysis required back in 1990. You can see it's a really complex set of calculations and hand drawings, but we do now. 34 years later, the kind of studies that they were saying were time prohibitive are now can be done in a matter of seconds. Please, next slide. And that while some parts of the city are pushing past those boundaries, other parts have really been pushing up against them. And this is really seen in the mid-rise document specifically, where you can see that the forms really dictated by the 45-degree angular plane, specifically in this case, have seen buildings move and push as far up against them as possible. Next slide, please. And that from an embodied carbon perspective, these guidelines have really had a series of unintended consequences. So you can see the angular plane resulting in a lot of transfer structures, step backs happening that have a lot of transfer structure as well. Historically, minimum parking requirements in the city of Toronto as well, driving that, the loading requirements, type G loading. All of these things, when combined, have a lot of basically impacts on embodied carbon through additional structure to achieve this. Next slide, please. And so when we started this project a year ago, we first looked at, we were asked to do a kind of first kind of mini study looking at the impact specifically of the rear transition plane in the mid-rise documents. And so these were the instructions from the urban design team. We have the existing massings. What happens if we have one step back? What happens if we have none for mid-rise? Next, please. And so we developed some counterfactuals. We took real buildings built in the city of Toronto or on the far right in construction and began to understand here by looking at a difference of changing the massing of the building and simplifying the structure. A few things happen. Embodied carbon decreases, and we're showing a range here, a very conservative range of embodied carbon that's based on understanding the multipliers associated with the upper floors of these buildings. And so you can see embodied carbon can drop dramatically, in some cases by 66%. And this is assuming the same structural system intensity or the same structural systems. But also what we're doing here is we're adding density to the site. The building on the bottom and in the middle can be built of a range of materials, not just reinforced concrete. And so all of these things are going to help not just address climate crisis, but also housing affordability. Next, please. So this first study, we then built it out. We looked at 10 buildings across the city, that represent different parts of the city and different typologies. And within those typologies, a range of different behaviors. Next, please. We worked, as mentioned at the beginning, closely with the city's environment and urban design team. And then we had a series of engagements, both internal and this video screen grab from an external working group, which a few of you attended a few months ago. Next, please. And out of this, we're going to highlight some recommendations, and then we'll share the toolkit, which gets into a few of them, or shows all of them, sorry. But the key ones, I think, to highlight for everybody today is that we're now at a point when, that we can move to performance-based, not form-based guidelines, that we could establish performance-based guidelines with quantifiable metrics where possible in place of form-based guidelines, and try to remove as much subjectivity as possible in design review, in urban design and planning frameworks. And so an easy example of this is the existing requirement for 5 hours of sunlight on an opposing sidewalk could be achieved in a multiplicity of ways. And so we should therefore allow design teams to demonstrate compliance with that performance requirement instead of prescribing a very formal solution, i.e. vis-a-vis the rear transition plane, for instance. Next, please. That the impact of building height and form, that generally speaking, we would promote greater simplification of building form and structure and design guidelines, and to revise the built form metrics in consideration of their structural design, envelope design, and related impacts. And illustrate this, these are two buildings that just got through approvals, both on very similar streets. On the left on Dufferin, on the right, I think it's on Sherbourne, but you can see how the urban design guidelines in one case has made the building envelope more complicated and also reduce the density of the site compared to the other, both of the same architect. Please, next. And the next one is back to the angular planes and step backs. And so this study, the simplification is the desire to eliminate and or reduce the requirements for angular planes and step backs, and to substitute angular plane requirements with site-specific performance requirements. Again, back to what are the things that we're trying to achieve around daylight, around wind, around thermal comfort. Next, please. That we should be looking to begin to establish some maximum window to wall ratios across guidelines. So the initial recommendations would be for the ground floors to have a maximum of 60% glazed area. This will reduce embodied carbon. This will improve operational performance. And then for upper floors, to go to 40%, which is still quite generous and above what the likes of Passive House might suggest for general window to wall. Sorry, and the last point there, Ryan, is then to also, question earlier from Forrest, was we should be moving towards a whole life carbon target for facades, understanding the upfront and operational impacts of these systems really need to be taken into account over the life of a building, given that facade systems generally have a much shorter service life than a structure. Next, please. We also looked at landscape and public realm around all of these projects, and our recommendations here were to establish a minimum area ratio for low maintenance, biodiverse, vegetated growing space within softscape, and maximize ratios for impermeable hardscape within total areas of required hardscaping. This is a bit of a mouthful, but basically, let's get softer, let's get more permeable, and let's get less concrete in our public space. Next, please. To remove minimum parking requirements. Now, Toronto's already done this, but so has Vancouver, so has Saskatoon, but all the other municipalities in Southern Ontario I'm aware of have not yet. And this data, you can see the proportion of embodied carbon related to the space below grade, which is principally in these buildings, underground parking. That's a product of parking requirements. So remove minimum parkings like Toronto, establish maximum parkings like in parts in Toronto and like the city of Boston for precedent. And let's connect long-term transportation planning ambitions to reduce our dependence on vehicles with short-term cost and carbon benefits, or reducing that space. If you want to make housing more quickly, you want to make it less costly, don't put underground parking in your building. Next, please. And connected to this also is the kind of basement loophole in our municipal bylaws. This is outside of urban design guidelines, but it sits right up next to it. North American municipalities have a very peculiar exemption around our definitions of gross floor area and how we do coverage. So in Toronto, this is bylaw 10.5.40.40. That basically is this kind of perverse incentive to build basements, and it's not unique to Toronto. All municipalities, if the one thing you wanted to do, reduce embodied carbon, this would be remove that loophole from our coverage calculations. Next, please. And above all, we need to be thinking about the future. So where are we now and where are we going? And take into account long-term climate conditions in the establishment and revision of your guidelines. Account for both access to daylight in the winter and shoulder seasons, as well as the need for shade and shadow and shelter in the summer. We think we're winter cities, we're cold climate. That is not always going to be the case. Heat is increasingly going to be a concern around how we need to be designing urban spaces, and then finally provide guidance that considers things like sustainable cooling and refuge in our cities. Thank you.
Sorry, guys, having a bit of a delay getting my controls back. But thanks, Kelly. That was really, really great. So many amazing findings there. And I really hope everyone can dig into the full report, because there's a ton of work and details in that report to build on all of that. So the last topic here of the three is around procurement, and around, how can we actually translate some of these ideas into some of the procurement specifications, and specifically around the materials and the fuels that we're using. So one big thing that came out of this, in which we realized we need to be doing it better as an industry, is just having better data collection and reporting. As anyone on this call who's done a whole building life cycle assessment can attest to, getting the data of the materials, that is the biggest challenge, right? It's nothing else. It's getting the bill of materials. So we can maybe think about ways to actually build that into the process, is to actually start having an inventory of how much our materials are being recommended in this design. Maybe municipalities can start requiring this as part of their submission document. This data is out there; it exists, right? It's just not being collected in a way that is streamlined for embodied carbon management right now. So there's a lot we can do on that front. And then we have some material specific recommendations. So as everyone knows on the call, and Lisa kind of mentioned, the Toronto Green Standard already has requirements at the building level, well, for tier 2 right now, for non-city buildings. But we can have those whole building requirements, but we can also have that work well with them material specific requirements. And we're seeing lots of these examples in other locations. And one example is the Government of Canada's ready mix concrete requirement. It's called the Standard on Embodied Carbon in Construction. This policy currently only applies to ready mix. In the future, it may apply to other materials, including structural steel is likely coming soon. But this requirement basically says if you're using a significant amount of concrete on a Government of Canada project, it needs to be 10% below an established provincial baseline. This is a very established process. We have industry average EPDs for the ready mix industry, and we need to look at what your strength class is, look at what the use is, and then you have to find an actual mix that's 10% lower than the GWP for that. So this is something that I don't think we need to be reinventing the wheel everywhere. I'm a strong advocate of, if it's working, let's use it. So I would really love to see more municipalities across the board, and even project teams just saying we're going to follow the same policy that the government already has in place and require 10% below these baselines. Sorry, actually, the last point I should also mention, there's also a difference between designing it like that and actually building it like that, right? So this is something that we saw in the research as well, is maybe it's time for us to update that requirement and have this be proven both at design, but also at delivery. When the concrete comes to the site, bring us an EPD and show that, what we're asking for in terms of GWP is actually what's being delivered. And I know large concrete folks like Lafarge and others are working on having these as designed and as delivered EPDs. So this is something I think the industry needs to be asking more for. In terms of steel, we can't point to the federal policy yet. As I said, it's probably coming from the Government of Canada, but it's not out yet. But we can point to some limits that have been published south of the border. And since we have a very integrated economy, especially around industry like steel, these numbers are a very good proxy for Canada. So the federal government, as part of the Inflation Reduction Act in the States, they've published a number of different limits, or embodied carbon limits. And you can see this example here on the slide for steel. So we would recommend that, again, policymakers and or project teams start targeting the top 40% limit based on the US numbers that have been published. And that's the same as saying 10% better than baseline, right? It's just using a different way to say that. So it's the same level of ambition we'd be asking for in these materials. by targeting 10% below baseline or top 40%. Those are kind of equivalent. So you can see here, we're recommending to do that. And there's some argument to be said, maybe we should allow for some, not all materials or not all steel needs to follow this, because there might be some very special applications. So we're suggesting maybe 90% of the steel on a project needs to follow these requirements. We've got kind of similar an idea for asphalt in the long term. The last paragraph here is the longer term. We should probably be using EPDs and do the same thing with asphalt, but we don't have nearly as many asphalt EPDs in the industry right now. So our current recommendation around pavements and asphalt is to basically maximize the recyclability and the circularity in the systems, or in the approaches. And one example is we saw that the Ontario Ministry of Transportation actually allows for quite a large amount of circularity, and it allows for lower carbon approaches like warm mix asphalt instead of hot mix asphalt. But it's always an allowance. It's not a requirement. So we would recommend, again, policymakers and project teams working on infrastructure projects to look at what the maximum that's allowable in those MTO documents, because they've determined that those are safe and acceptable. And let's, instead of just allowing up to that, let's target that, right? Target the lowest carbon solution in the range that's allowable. So I think this is a really easy thing we can do, but in the longer term, again, we would want to see EPDs for actual asphalt mixes and then be below a number that drops over time. And then we want to talk also about clean construction. This is something that I think hasn't gotten a lot of airtime until recently, but there's things we can do on the construction site in terms of the fuels that we're using, and ideally not using fuels in the future, but going towards electric equipment. This is an example that in the top right corner, that's an electric truck in Ontario that Anya's team actually at Multiplex put together a great symposium of electric construction equipment that's available in Ontario, and these are ready. These are here. If people tell you there's no electric construction equipment yet, that's no longer the case. So the large tool suppliers that are renting out to the Elistons and the PCLs of the world, they have electric equipment. Maybe not everything, but they do have some models. So we should be asking for this and pushing for this where possible. And where not possible, we should be using more biofuels, right? A lot of people are using B5, but we can go to B20. Lots of organizations are using B20 in all of their in the warmer months. And then we also, if we really are, want to be serious about this and are willing to pay a little bit of a premium, we can go to renewable diesel, which is a significantly lower carbon footprint, and you can use it all year round. We don't have a big supply of renewable diesel right now in Ontario, but again, we need to be asking for these things and requiring these things for industry to meet the need. In Oslo, in Norway, they put in requirements like this, and the first few years people were non-compliant, but it sent a strong market signal, and within a few years the market was able to respond and provide these solutions. And now the construction sites in Oslo are zero carbon. They're fully electric, and it's so much healthier both for the planet but for the workers and the local community. So again, there's many benefits to doing these things. So I'm going to hand it back over to Kelly. He's going to show us around the toolkit a little bit, and I will let Kelly share his screen for that.
Right on. Thanks, Ryan. So we'll share this out later, but the toolkits, you can see it's a spreadsheet based. We've got some basic instructions here on the front, and we've got it organized along the bottom as for the order of today's presentation. Suggestions around policy, then clean construction, urban design, and procurement. And won't go through all of them, but just you can see, generally speaking, under the policy, we've got those subheading topics, the question that they seek to answer, providing some context to those answers, our recommendations, and then also examples and link out kind of signposting to policies elsewhere. So here's a kind of thumb through all of the policy recommendations we've got. Likewise, then more on a project base. So that audience was target policymakers. This is the target is for projects. And so people working at municipalities and for project teams themselves, question to ask themselves and of projects. So adaptive reuse here, you can see Ryan's put the question together, like, has your project considered reuse potential? And then, working through these, the intent is to kind of move top to bottom through a project and think about how you can respond to this, or how your design team and the design project itself can respond to some of these prompts. So we have circularity, we've got questions around urban design, that help kind of guide lower carbon design practices and in the context of what we were just presented, and then finally procurement. And this will be the intent here is that this can help municipalities change policy and also guide projects through approvals. I'll stop sharing, and we've got 10 minutes for some Q&A.
That's the end of the formal slide. So we welcome discussion, questions, comments.
Thank you, Ryan, Kelly, and Lisa. There has been a few questions on the chat. I know, Lisa, thank you very much for answering a bunch of them. I'll read a few that maybe have not been answered yet. There was one from Brian. At what stage of design were the LCAs completed? And is there a difference between doing the LCAs at different design stages?
I can field that one, Ryan, if you want. Yeah. So the 10 buildings we looked at, they range from projects that are constructed. So we were working from the CD sets, and in I think 1 or 2 instances we were working with the DD sets, with the 100% DD kind of permit approvals drawings. But by and large, the data sets we were looking at were from the construction document sets.
Thank you, Kelly. Lisa, I know you answered about in terms of getting resistance from project teams. Also, there was a question about carbon budget for the city. Lisa, do you want to add anything else to what you already kind of put in on the chat?
Well, I asked our environment climate division, so I'm just waiting for any more information, but that's kind of what they sent me. So I think they're working on the annual carbon budget, but we do have that bylaw that requires us to produce it now, which is a big step forward.
Yeah, and the city does, they published, I think it was last year, a consumption-based emissions inventory, which is also something really interesting and relevant to the embodied carbon discussion. Because as a lot of you on the call know, it's not just about the emissions we produce in Toronto, but it's all about the emissions associated with the materials that we use in Toronto. So there's a lot of materials that are made outside of Toronto and we ship it into the city, right? So we should be looking at that and thinking about reducing that. And the city has already taken a very strong first step on that with their consumption-based emissions calculation.
I guess the question from Natalie posed earlier to you, Lisa, and I might take a stab at answering it too. I mean, the question around so just to repeat it here, at least from Natalie, on the civic projects, did you find city staff, especially those that weren't typically climate actors or literate, were generally supportive and open to finding ways to reduce? And I would say, thinking back about past both of these engagements that we've done, both of the TAF-funded work that Ryan and I have been working with Lisa and the team on, early on, Lisa, I think you made a comment like embodied carbon's been a really useful topic that neutralizes some of the kind of siloed perspectives. It's something that's between departments and cities has allowed conversations to happen that might previously have been a bit more contentious. And so I think generally speaking, my observation would be, and I'm parroting, I think some of what Lisa is seeing, are just beginning to understand how we've engaged in this specific piece of work across more city departments that, embodied carbon emissions, climate, like gets everybody around it. I think people want to act on this and see how they're a part of it. So generally speaking, this work has helped break down some of the, say, previous existing silos, walls between departments, perspectives, to create a bit more, action. I don't know if you'd agree with that, Lisa, but that's certainly been my reading.
Yeah, definitely, Kelly. I mean, so when I was responding to Natalie, I was thinking of the 2 pilot projects that I mentioned from phase 1, but yeah, all the work that Kelly's done in phase 2, it involved, and even with Ryan too, the 3 different topics involve so many different departments. Actually, we'd have to count up how many were involved in the discussions there, but very cross-disciplinary. And, there is a certain protectiveness around things where, well-established principles around urban design, for example. But, all of this, does create a framework, I guess, to talk about things in a different way. And definitely to be thinking about where we go in the future, because climate change is such a big pressure on all of us.
Yeah, maybe I can speak to the question from Tracy asking about infrastructure and embodied carbon management. So as part of the working groups that we had during this meeting, we did have, as Lisa just mentioned, we did have folks from the TTC, from engineering, from streets. So there was a very strong infrastructure contingent in these discussions. And that a lot of those material specific recommendations are obviously applicable to infrastructure. So it's true that we don't have design recommendations of the type that Kelly was talking about for infrastructure right now, but I think all or most of the circularity and the procurement recommendations, I think almost all of those apply to infrastructure as well. And as part of this, I didn't mention it in our pilot project slide, but we did actually talk to infrastructure teams about implementing the lower carbon ready mix requirements, and they're actually doing that for a number of projects. They were actually doing it before we had engaged with them, but this kind of like reinforced that they were on the right track and what they were doing made sense. So the city has already started experimenting with using lower carbon ready mix in infrastructure projects, including wastewater and sewage sewer design. So that is already happening now.
Thank you for that. We have a very technical question here. Do you foresee the new seismic requirements from the OBC impacting LCA targets and what's achievable?
Kelly?
Let me come back to that. We want some data, I guess, just to compare what that's doing to the buildings here. But generally speaking, having worked in seismic zones before, I think you would expect a slight uptick in structure, but nothing too substantial, I think. And again, back to simplicity of building form to relate it back to some of the suggestions. If you're designing for seismicity, you want a simpler plan to work around. And I think these things aren't necessarily working against each other. So, you know, these are things that we need to take into consideration, but I don't see that being a huge impact on the targets. But I think the other thing about the targets too, you know, is that as more data comes in, things are going to be refined. The targets are going to, you know, a broader data set is going to help create greater fidelity. And I think that the direction of travel right now, the City of Toronto does have a study ongoing, doing an archetypal study to really sharpen up, you know, future policy and the targets that projects would need to be defined against.
There's also another question from Tina, asking about if there's any standards or approaches to evaluating reclaimed wood so that it can be used in new products. I think the short answer to that is no, not yet. I guess not yet would be the better answer, because this is definitely something that has come up quite a time and again. And the CSA, who creates standards, they are very aware of the need for a standardized approach and process for reuse of secondary materials. So I guess, yeah, to say on that one is stay tuned. It's definitely being discussed by standards organizations. And I would say not just wood, but also that very much applies to structural steel as well. I know there's a very active discussion now in the steel industry about how we can make better use of structural steel beams that are coming down from sites instead of going and have them, you know, recycled, which they're already doing that, putting it in electric arc furnaces and making new steel out of it, which is great. But it's even better to reuse it without having to do that, right? Reuse it as structural steel that it's already in the form for, finding a right application for that. So there is a whole movement around grading that, making sure it's fit for reuse, and then having that done. So there'll definitely be more on that in the coming years as the industry gets up to speed on how to do that most effectively.
Great. Thanks, Ryan. I guess with just 2 minutes left, just one more question, and that's Lisa, could we sneak in some incentives into policy for material reuse?
It would be nice. Yeah. That's something that we really have to figure out. I'm not sure that we have quite the answer to that yet. I mean, we certainly have an incentive when it comes to our tier 2 levels of the green standard, which include requirements for reuse of building materials, salvaging and reuse, already quite high requirements. But all of our green standards, tier 2 and above, have one incentive associated with it, which is called the DC refund, development charge refund. where developers get a partial refund for high performance buildings. So it does include those kind of objectives around embodied carbon reduction and salvaging and reuse of building materials. But other ways to incentivize in terms of the kind of things that Ryan found in the jurisdictional scan and those kind of things, those are things that, you know, in the permit process, for example, that we have to really look closely with our other divisions and see what's possible to do.
Thank you, Lisa. I think we're at time right now, so thank you very much, Lisa. Thank you, Kelly. Thank you, Ryan. It's been a very informative presentation. Really a lot of activity in the chat as well. Everybody is very keen on the subject, so it's really great to see that everybody is also, there's more people coming on board. There's less of that resistance, so it's really great to see. Thank you very much. The toolkit will be shared, and then we'll also have a recording of the session posted on the CLF website. Thank you very much and have a great day.
Thanks, everyone.
Thanks, everyone.